Hello everybody. So today we're going to take a look at section 7.4. We're skipping over 7.3. It's just a graphing lab. We should be pretty familiar with solving these systems graphically. That's what we did in 7.2 already. Remember that we are looking for the point where the two lines intersect or cross over. That's the point where the x and y values satisfy both of the equations, and that's what we consider to be a solution to the system. But now what we're going to do is we're going to forego using graphs altogether, because in fact it is possible to solve these systems of equations using algebra. We don't have to use graphs anymore, and you could even argue that this is going to be a more effective strategy because sometimes when we use graphs, the lines that we get, they don't necessarily always cross over right on the grid lines. So sometimes we end up with approximate solutions to our system. Sometimes we have to estimate, and that, depending on the situation, that's not something we want to do. We more often prefer an exact solution. Okay, so there's two ways that we're going to learn to solve systems algebraically in this course. This week and next week, we're going to use what's called the substitution method. After that, we're going to take a look at the other one, which is called elimination. One thing I want to talk about before we get started is the ability to even know if we can solve a system. For the most part in this class, you will be able to solve, but I do want to put it down in writing here just for the sake of completeness. So in order to solve a system, or I should say in order for a system to be solvable, solvable. Let's see, how do I want to say this? We need at least as many equations as we have variables. So what does that mean? So something like x plus y equals 2 and 2x minus y equals 3. Here we have two equations and we have two variables. We have x and we have y. So in this example, we do have as many equations as we have variables. So that would be solvable. While something like this system, let's say x plus y plus z equals 2 and x plus 2y minus z equals -9, this one has two equations, but it has three variables. It has x, y, and z. So it does not have at least as many equations as it does variables. So this one would be not solvable. Okay, but like I said, pretty much any system I give you is going to be solvable. So what I'm going to do is I'm just going to show you the method step by step with an example. Okay, so let's consider this system. 3x plus 4y equals negative 4. That's our first equation in the system. And then x plus 2y equals 2 is our second. So in order to begin the substitution method, we have to pick one of these equations. So we'll say pick one equation from the system, and write it in terms of one of the variables. When I say write it in terms of, that means we isolate for it. So if I say write it in terms of y, that means we're going to change the equation to say y equals something. What I'm going to do is I'm going to take the second equation here. I'm going to take x plus 2y equals 2, and I'm going to write it in terms of x. Why am I doing that? Well, we have four options here, right? We can take the first equation and write it in terms of x. That's our first option. Or write it in terms of y. That's our second option. And then we can do the same thing with the second equation, either write it in terms of x, which is our third option, or write it in terms of y, which is our fourth option. So why did I pick writing the second one in terms of x? Well, if you notice, every variable in the first equation, it has a coefficient. And so does the y, or the y variable in the second equation. The only variable that does not have a coefficient in front of it is the x value in the second equation. What that means for us is that's one less step of algebra for us to do in order to get that variable by itself. That x is already by itself in the second equation. I would encourage you to do that. If you're going to write any equation in terms of one variable, take a second to look and see if any of the variables do not have a coefficient. It's going to be one less step for you to do, which means there's going to be less opportunity for you to make an error. So I'm going to take the second equation, I'm going to write it in terms of x. So I got x plus 2y equals 2. I want to write it in terms of x, so I need to move this 2y out of the way. It's a positive 2y. So if I want to get it out of the way, I got to subtract 2y from both sides, of course. When I do that, these cancel out. And what I'm left with here is just x equals negative 2y plus 2. And that's isolated. The x is by itself. That is now written in terms of x. You might notice here that if I did choose, or if this x variable did have a coefficient, my next step would then to be divide everything by the coefficient. So again, another step, but we chose a good variable to isolate here, so we don't have to do that. Okay, so we have a statement here, right? We know that for the whole system, x is equal to negative 2y plus 2. Okay, so why do we care? Well, for both equations, not just the second equation, but all the equations in this system, we know now that every time, so what this means is every time we see x, we can write negative 2y plus 2, right? Because they're equal. X is equal to negative 2y plus 2 in this system. That's a true statement always for this system. So what we're going to do now is we're going to take a look at the other equation in the system, and every time we see x, in the other system, or sorry, in the other equation in the system, instead of x, we're going to write negative 2y plus 2. And something interesting is going to happen. So I'll say do this substitution. That's what we call it, the substitution method. Do the substitution in the other equation. Okay, so take my other equation, which is 3x plus 4y equals negative 4. Okay, so where's my x? My x is right here. Okay, so I'm going to come in, I'm going to make the substitution. So that 3 stays where it is, but now put your brackets in, it's going to help you. Instead of x, we have negative 2y plus 2. So that's my substitution, right? That's what we found out in the first part there. And then you make sure you copy everything else down. So we got that 4y equals negative 4. Okay, so you might say we just complicated this equation more. This is now bigger, it's harder to work with. But what did we do? What was the point? The point of doing this, now if you look, there's no more x in that equation. This equation now contains only one variable. It contains only the variable y. So now, because this equation contains only a y variable, we can solve for y, right? When we started this system, both equations had an x and a y, right? In all the equations, in both of them. So we couldn't go through and just say x is a number, y is a number. It was impossible. We couldn't do it. But now, because we only have one variable in one equation, we can simplify this. We can get y by itself to see what y is equal to, and that's half our solution, right? We want to see what x is equal to. We want to find what y is equal to. So now, because we only have y in this system, we can solve for it and get half of our answer. Okay, so what we're going to do is we're going to solve for y. So we're going to have to expand, right? We're going to have to distribute this 3. We're going to have to multiply it in using our distributive property, right? So for that one, so we got 3 times negative 2y. It's negative 6y. 3 times 2, 6. Plus 4y equals negative 4. Collect our like terms here. So negative 6y plus 4y is going to be negative 2y. We want to get that y by itself. So let's get rid of that negative 6 first. So, get rid of that positive 6 by subtracting 6. So that goes to 0. Right. So then we have negative 2y still, that doesn't change. And then on this side we had negative 4 minus 6, so that's negative 10. And then we want to get that y by itself. That's a negative 2y being multiplied, it's a negative 2 being multiplied into the y. So the opposite operation of that is going to be division by negative 2. So when we do that, those 2's cancel out. So we get y is equal to negative divided by negative is a positive, 10 divided by 2, 5. So y is 5. That's half our answer. Okay. So now we know what the y coordinate of the solution is going to be. So now all we have to do is we can do the exact same thing, but now we know what y is. So now anytime we see y, we can write 5. So we can go back to any two of our initial system here, and for either of these y's, we can put 5 into it, and after we do that, we'll just have the x value left over, and we can calculate what x is going to be, and then we'll have our complete solution. Okay, So what I'll do is I'll come down here. We'll use the second equation for this one, just because it's easier to work with. So this is, I'll reiterate, half our answer. So now we can substitute this into either equation. Doesn't matter which one. Because y is equal to 5 in both of them. But I'll use the second one just because it's easier. So we'll say, we'll use x plus 2y equals 2. Make our substitution here. So we got x plus 2 and y is equal to 5. It's a lot easier than the first substitution. And that's equal to 2. And now this is like a grade 8 or grade 9 algebra question. What is x equal to? Well, do BEDMAS first. This simplifies, of course, to 10. 2 times 5. And we want to get that x by itself. So we have x plus 10. So if we want to get that by itself, of course, we want to use the opposite, which is subtracting 10. Doing so cancels that out. And we're left with the second half of our answer, which is x is equal to negative 8, because 2 minus 10, of course, is negative 8. Okay. So we can say, therefore, the solution to the system is x equals negative 8 and y equals 5. Or we could just simply write it as the point, negative 8, comma 5. If we were to graph both of these solutions, or if we were to graph this system, both of these equations, we would find that the part where they intersect or cross over is going to be the point negative 8, 5. Okay, so a little faster, I think, than graphing, and it gets us to an exact answer. So I think I'm going to end it there for this week. Let me see here what I want you guys to work on for this week. So the assignment is going to start on page 425. And let's see, we'll do question 4 and 5 and 6. So let's say we'll do questions 4 to 6. Let's do that. Let's do questions 4, 5, and 6 for now. And then I'm going to do another example with you guys next week. Show you a little trick that makes some of the questions easier. And there's a few word problems as well, where you're going to have to use the strategies we learned in section 7.1 to build your own system and then move on to solving it using this method here. Okay, but don't worry about that for now. Just work on getting through questions 4, 5, and 6, and then you'll be able to do the next part pretty easy. All right, so that's all for this week. I hope you guys are staying safe out there and nobody's feeling too lonely and you're staying connected with your friends and your family. So hope you guys are doing okay, and I'll see you next week, okay? Bye.